This is the budding light of hope and knowledge, the delight of Sri Prakash educational institutions, spreading academic brilliance in all directions.
Hello students, welcome to Sri Prakash Educational Institutions online video content. This is the second volume of chapter 8 Motion from 9th standard physics and myself T. Vinod. Instructions to be followed. Be ready with your textbook, notebook and pen. Watch and listen to the video carefully. Jot down all the important points in your notebook. In today's agenda, we will learn the word of the day, recite the previous knowledge from Volume 1, definitions of important terms in motion, SI units of physical quantities related to motion, and summarize the concept presented in this video at the end. Word of the day. Acceleration, noun, meaning the increase in something's speed or its ability to go faster. Conjugation, accelerate, accelerated, accelerating, accelerates. Usage, the car delivers quick acceleration. Learning outcomes. Students will be able to understand the different terminology used in motion lesson, identify the relationship between different physical quantities related to motion, understand the difference between speed and velocity. Speed. To understand this, let us witness a running race between the three characters A, B and C. Now the race begins. C is super fast, B is fast and A is slow. C has completed in just 15 seconds. B took 40 seconds to complete the same distance and A, since very slow, he took 1 minute to complete the race. Now there is a comparison with distance traveled and time taken. If we have these two, then we can easily calculate the speed. Going to the definition of speed. Speed of a body is defined as the distance traveled by it in unit time. The formula for speed is speed equal to distance by time. The symbol for speed is V. V is equal to S by T. SI unit of speed is meter per second. Uniform speed. Consider a ball rolling on a smooth, frictionless surface. Since there is no opposing force, it covers equal distances in equal intervals of time, moving with uniform speed. So the definition of uniform speed is a body is said to be moving with uniform speed if it covers equal distances in equal intervals of time throughout its motion. Example, motion of a ball on a frictionless plane surface. Non-uniform or variable speed. A body is said to be moving with non-uniform or variable speed if it covers unequal distances in equal intervals of time. Example, motion of a car on a busy road. Shall we go for a ride in that car? Hope you enjoyed the drive. instantaneous speed. This is a speedometer of a vehicle which shows the speed at that particular instant of time. According to the definition of instantaneous speed, it is the speed of a body at that particular instant of time. The speedometer of a vehicle measures the instantaneous speed. Average speed. It is the ratio of the total distance traveled by the body to the total time of the journey. Formula is average speed is equal to total distance traveled by total time taken. Consider the example in which a car travels from town A to town B. As the car reaches town B, let us calculate the average speed. Distance between two towns is equal to 150 km. Time taken for the journey is 2 hours and the average speed of the journey is total distance 150 km by total time 2 hours. So it is 75 km per hour. Velocity. The velocity of a body is the distance traveled per unit time by the body in a specific direction. A similar kind of definition we have read for speed. The only difference is the direction should be specified with velocity. So velocity will be a vector quantity. Alternate definition for velocity. The rate of change of displacement of a body is called the velocity. Formula. Velocity is equal to displacement by time. SI unit of velocity is meter per second. Uniform velocity. If a body travels equal distances in equal intervals of time along a particular direction, the body is said to be moving with a uniform velocity. In most of the cases, the bodies which are in motion may not exhibit uniform velocity. A special case shown in the image, the rain falling with uniform velocity towards the earth. This can be considered an example for uniform velocity. Non-uniform or variable velocity. If a body moves unequal distances in a particular direction in equal intervals of time, or it moves equal distances in equal intervals of time, but its direction of motion does not remain the same, then the velocity of the body is said to be variable. We see most of the moving things exhibit this non-uniform velocity. Example, motion of vehicles on the crowded road. Instantaneous velocity. Velocity of a body at that particular instant of time. We can calculate instantaneous velocity of a body with the help of calculus, which you will learn in your higher classes. Average velocity. It is the ratio of total displacement of the body to the total time taken. Formula. Average velocity is equal to total displacement by total time taken. Average velocity. Special case. If the velocity of a body changes at a uniform rate, then the average velocity is given by the arithmetic mean of initial and final velocity for a given period of time. That is, average velocity is equal to initial velocity plus final velocity by 2. VAV, symbol for average velocity, is equal to U plus V by 2, where U represents initial velocity and V represents final velocity. Distinction between speed and velocity. Speed. The distance traveled per unit time by a moving object is called its speed. Velocity. The distance traveled per unit time by a moving body in a particular direction is called its velocity. For velocity, we are including direction also. Speed. It is a scalar quantity. The speed does not tell us the direction of motion. Velocity. It is a vector quantity. The velocity tells us the speed as well as the direction of motion. Speed. The speed is always positive. Velocity. Velocity can be positive or negative depending upon the direction of motion. Acceleration. You can see in the image the train leaving a platform. As the train moves away from the station, the velocity of the train increases. According to the definition, acceleration is defined as the rate of change of velocity. Formula: acceleration is equal to change in velocity by time taken. A is equal to v minus u by t. SI unit of acceleration is meter per second square. Negative acceleration, retardation or deceleration. All the three represents the same. Let us consider a race in which the students are running with greater speed. Once they reach the finish line, their velocity gradually decreases and they come to rest. So after crossing the finish line, the decrease in the velocity represents negative acceleration or retardation, or it can also be considered as deceleration. Uniform acceleration. If the velocity of a body increases at a constant rate, it is said to have uniform acceleration. Example, a freely falling body onto the surface of the earth is under uniform acceleration due to gravity.